Okay, today at the station we are going to be doing a worksheet together. If you do not have this worksheet, please get it. It should be at the center of your table. Just a reminder, you can pause this video whenever you need to. So I'm just going to start by writing my name at the top so I know that it's mine. And then maybe you can write the class and date too. Okay, Energy Day 4 worksheet. Kinetic energy is, we have a multiple choice question here, energy of motion, something that is moving right now, or is kinetic energy stored energy, something that is going to move in the future? Take a few seconds and choose one. Okay, and I know that kinetic energy is something that is moving right now. That's what gave it away for me. It's energy of motion, so I'm going to circle A. If you do not have A circled on your paper, make sure you have A circled on your paper. Okay, number 2. Potential energy is energy of motion, something that is moving right now, or B, stored energy, something that is going to move in the future. Okay, I know that kinetic energy is energy of motion, so I can get rid of that one right away. And potential energy is something that is going to move in the future. So I know that it's B, so I'm going to circle B. If you do not have B circled, make sure you have B circled on your paper. Moving on. Today, we learned about the law of conservation of energy. You should have this definition in your notebook. So the law of conservation of energy states that energy cannot be created nor destroyed, or does it say B, energy comes and goes, it can be created and destroyed depending on the environment. If you need to look back in your notebook, please do so. Okay, I know that the law of conservation of energy states that energy cannot be created nor destroyed. It's only transformed. It's only transferred from one type of energy to the next. Right. Image 1. Let's move on. So this is image number 1. We have a ball right here and a ramp, and we can assume that gravity is going to pull the ball down the ramp. So question 1, what type of energy does the ball in image number 1? What type of energy does the ball have in image number 1? So ask yourselves the questions. Is it going to move in the future? Yeah, it's going to move in the future. So I know it has potential energy, and follow along, circle potential energy. And is it moving right now? So I know the ball is not moving right now. If it were moving right now, it had 3 little lines behind it, and it might be farther down the ramp. So it's not moving right now. I'm just going to cross out kinetic energy because it does not have kinetic energy. Make sure your paper looks like mine right now. Okay. How much energy does the ball in image number 1 have? So I know it has potential energy and no kinetic energy. So I can get rid of B right away because it doesn't have kinetic energy. So C says 25% potential energy. Okay, it has potential energy, so we're good there. And then so does D. D has potential energy, so we're good there. C says 75% kinetic energy. So I know that image number 1 does not have any kinetic energy. It has 0% kinetic energy. So I can get rid of that one too. D says 75% potential energy and 25% kinetic energy. So again, it has 25% kinetic energy. I know it has 0% kinetic energy, so I can get rid of that one too. So the answer is A, 100% potential energy is the answer. So I just want to bring your attention to something. This has 0% kinetic energy because it does not have kinetic energy, because it's not moving right now. But it's going to move in the future, so we know it has potential energy, and it only has potential energy. When something only has potential energy, we can say it has 100% potential energy because all of the energy is potential, every single drop of it. Okay, let's move on to number 3. So explain your answer for question number 2. You can choose more than one. Okay, the ball is going to move in the future. That's true. That's potential energy. That's why I chose potential energy up here. And then the ball is moving right now. No, the ball is not moving right now, so I did not choose that one. See, the ball has a long way to go down the ramp. So if I look back up here, the ball does have a long way to go down the ramp. It has all of the ramp left to go. So that's true. So I can circle that one. And the ball is already pretty far down the ramp. That's not true. So your paper should look like mine. Should have A circled, and C circled. If you need to rewind or pause, make sure you rewind or pause. Okay, moving on to the next page. Okay, image number 2. So just this little bit. Okay, what type of energy does the ball have? Reminder, ask yourselves these 2 questions, and I'm going to give you a few seconds to answer this one by yourself. What type of energy does the ball have in image number 2? Okay, so is it moving right now? You remember those 3 little lines I told you about? They're right here. So is it moving right now? Yes. So we know it has kinetic energy. Is it going to move in the future? Well, yeah, it's not just going to stop right there. It's going to keep going down the ramp. So I know it has potential energy because it's going to move in the future. Okay. How much energy does the ball have in image number 2? So I have both potential energy and kinetic energy here. E and F only have 100% potential energy and 100% kinetic energy. Since these don't have both, and this ball has both, I'm going to cross out both of those. Because neither one has 100%, because if this one had 100%, this one would have 0, and we wouldn't have circled it. If this one had 100%, this one would have 0, and we would not have circled that one. So we need to circle both, so it has both types of energy. That's why this one doesn't work, and that's why this one doesn't work either. Okay, let's look at G and H. 25% potential energy and 75% kinetic energy. Or 75% potential energy and 25% kinetic energy. So we need to go and look back up at the image and decide what it has more of. Does it have more potential energy or more kinetic energy? So to do this, I might draw a line, maybe right here. That's where the ball is. And it still has a long way to go down the ramp. So I can say that it has a lot of potential energy. A lot of potential energy. When someone has far to go, maybe in their career, maybe in math class, you have a lot of potential. That means you have far to go, like you can go really far. This ball can go really far, so it has a lot of potential energy. So let's go down to the question again. We can say 25% and 75%, or 75% and 25%. So this 75% is way more than 25%. So it has more potential energy than kinetic energy, and that's true. I'm going to circle that one. Now this 25% and 75%, that's less. 25% is less than 75%. And since this image has a lot of potential energy, I need more potential energy. So H is the answer. Okay, let's move on. Question number 3. Explain your answer for question number 2. Okay, the ball is going to move in the future. That's true. That's why it has potential energy. The ball is moving right now. That's true too. It has kinetic energy. It has both potential energy and kinetic energy. That's good. The ball has a long way to go down the ramp. Yeah, that's true. If we look up here, the ball has a long way to go down the ramp still. It's only up here. Okay. Or the ball is already pretty far down the ramp. That's not true. Okay, so I circled E, F, and G. Reminder, you can rewind and pause if you need to. Let's move on to page 3. I'm going to give you some time. Try this one on your own. Pause this and try this one on your own. And then press play again when you're ready to check your answers. Okay, let's do this one together. So image number 3, I'm going to draw a line right here and ask myself, is it moving or is it going to move in the future? Yeah, it's got like some way to go. The end of the ramp is right here, so it's got some way to go. So I can say yes, it has potential energy. Okay, is it going to move? Is it moving right now? Yeah, those 3 little lines are there. It's already moved a lot of the way down the ramp. So yes, kinetic energy. Make sure you're checking your answers, and if you don't have the right answers written down, write the right answers down. Okay, how much energy does the ball have in image number 3? So since it has both potential energy and kinetic energy, I can already get rid of these 2. K says 25%, that's less potential energy and more kinetic energy, 75% kinetic energy, or 75% potential energy and 25% kinetic energy. So I have more potential energy here and less kinetic energy here. If we go back and look at the image, the ball has already gained a lot of speed, gained a lot of kinetic energy rolling down the ramp, and it only has a little bit left to go in potential energy. It only has a little bit of potential. So I need the less potential and more kinetic. So I'm going to circle K. This one would be what we saw in image number 2 when it had a lot of potential and just a little kinetic. You can think of kinetic energy, if you need to, about speed. If it has more speed, it has more kinetic energy. This ball has gained a lot of speed rolling down the ramp, so it has more kinetic energy. Okay, question number 3. Explain your answer for question number 2. You can choose more than one. Okay, the ball is going to move in the future. That's true, it has potential energy, so it's going to move in the future. The ball is moving right now. That's true, has kinetic energy. The ball has a long way to go down the ramp. I don't know if that's true. Has a little bit of way to go down the ramp, so maybe I don't circle that one. The ball is already pretty far down the ramp. That's more true. I'm going to circle that one. Again, check your answers. If you do not have what I have, make sure you have what I have on your paper. Now, if you're done, you can go take the Google Classrooms quiz. It's a Google Forms link, and you can fill that out.